Good evening, everyone. On behalf of Village Sri Lanka, it is my pleasure to warmly welcome you all to this exclusive webinar titled Power Up Your Flight Path to the Future. This session is part of the Ignite 10 mentoring program by Village Sri Lanka, designed to spark meaningful knowledge sharing, innovation, and growth among professionals in the fields of logistics, aviation, and MRO. Tonight's focus is on powering the skies, smart warehousing and logistics for next-gen airline MRO, a topic that resonates deeply in today's ever-evolving global supply chain and aviation landscape. And we are privileged to have an esteemed speaker who will share his expertise on this exciting topic. Before we begin, here are a couple of ground rules to ensure a smooth session. Please keep your microphones muted throughout the session to minimize the background noise. If you have any questions, feel free to ask them in the chat or raise them during the Q&A session at the end. Let us now take a moment to watch a short video about Village Sri Lanka, giving you an insight into its mission, initiatives, and contributions. Thank you, everyone. Now, to formally commence the today's session, I cordially invite Professor Renuka Herath, Chairperson of Village Sri Lanka, to deliver the welcome address.
Right. Thank you, Pratagi. And of course, thank you very much for the membership development pillar led by Dr. Priyangana Jayasundar and the team for organizing yet another webinar under the Ignite program. Of course, being the object of the Ignite program to develop the next generation of the logistics and supply chain. That's been our motto, of course. So we have been doing so many programs, including webinars, and then we have been taking our students who are following logistics and supply chain management degrees in Sri Lanka for different visits like airport, Colombo port, and factory visits. Of course, the purpose is to enhance the hands-on experience of the students, of course, because they of course get to see they get to obtain the knowledge about their subject matters, but of course they also have to have an idea before they are entering the industry. If they can have an idea about what's happening in their industry, that will be very useful. So with that objective, of course, today we are going to have another webinar, and the resource person is Mr. Visuddha Piyathilake, engineering, warehouse and logistic manager, Emirates Airline. You are very welcome, Mr. Piyathilake, and thank you very much for agreeing to be a resource person of this particular program. Being aviation is an integral part of our industry. When you say logistics, we have maritime, aviation, land transport. So it's really good that we are actually looking at that aspect also, what's happening in that aspect, in that vector of our industry. So that will be very useful for the, I think mostly the students must have joined for this particular webinar today. So you're very welcome, Mr. Piyathilake, for this program. And also the members of WILAT, the EXCO members, and the entire team of membership development, Dr. Priyangani Jayasundara, everyone, and also the volunteer students who are supporting us all the time. And of course, most importantly, the people who have joined today to witness this particular webinar. We can see around more than 100 participants, so which shows the enthusiasm of the people who have joined and the willingness to get that knowledge of that particular industry. So thank you very much, Pratagi, and Dr. Priyangani Jayasundar, over to you.
Thank you, Madam. It's now time to introduce our keynote speaker for the evening. To do the honors, I would like to invite Dr. Priyangani Jayasundara, Project Chair for Ignite 10 Mentoring Program by Village Sri Lanka. Over to you, Madam. Madam, you are muted.
Priyangani, you are mute. Yes.
Thanks, Renuka. Right. Thank you, Professor Renuka, for your kind welcome address, and thank you, Pratagi. Aibowan, good evening, dear ladies and gentlemen. It's my great pleasure to introduce today's speaker, Mr. Visuddha Piyathilake, a truly distinguished and accomplished supply chain professional with over 17 years of experience across the commercial, aviation, and shipping industry. Visuddha is an engineering graduate of the University of Moratuwa and holds an MBA from the University of Leicester, UK. He also holds an international diploma in supply chain management from International Trade Center, and it's a certified project management professional from the Project Management Institute, USA. Also, he is a life member of the Institute of Supply and Material Management, ISMM Sri Lanka, and an associate member of the Institution of Engineers Sri Lanka, IESL. Currently, he serves as the engineering, warehouse, and logistic manager at Emirates Airline, based in Dubai, UAE, where he has been making significant contribution to aviation supply chain operation for over a decade, particularly in MRO, logistic, and warehousing. Prior to joining Emirates, Visuddha worked at South Asia Gateway Terminals, SAGT, in Sri Lanka, where he began as an implant trainee in 2006 and advanced to be the technical inventory manager, where he served from 2008 to 2013. During that time, he led impactful inventory optimization initiatives that delivered major cost savings. In 2010, representing ISMM Sri Lanka, He participated in the ITC MLS Network Roundtable in Nairobi, Kenya, where he was declared the world winner of the My Success Story in Supply Chain Management competition, based on the measurable cost-saving success of his work at SAGT. Visuddha also contributed as a visiting lecturer at ISM, sharing his expertise and uplifting future professionals. On a personal note, I am especially proud to say that Visuddha is one of my most outstanding former students. His commitment, passion for excellence, and expertise, especially in aviation, MRO, logistics, and warehousing, are truly commendable. It brings me great personal joy to see how far he has come. And I believe his journey is one that will inspire our mentees and many of us here today. Please join me in warmly welcoming Mr. Visuddha Piyathilake to today's session. We look forward to learning from your inspiring journey and the valuable insight. Thank you, Visuddha, joining us today. Over to you, Prathagi.
Thank you, Dr. Priyangani. Ladies and gentlemen, it is now time to dive into our Please join me in welcoming our distinguished keynote speaker, Mr. Visuddha Piyathilake, Engineering Warehouse and Logistics Manager at Emirates Airline Dubai. With years of experience managing global aviation logistics and warehouse operations, Mr. Piyathilake brings with him a wealth of insights on how smart warehousing and next-gen logistics are shaping the future of airline MRO. So without further ado, let us now welcome Mr. Visuddha Piyathilake. Over to you, sir.
Thank you, Prathagi. Can I first check whether am I audible to you all?
Yes, sir.
All right, thank you. First of all, let me start with my thanks to Dr. Priyangani Jayasundar. It was a pleasure, actually, accepting this invitation and being part of this great evening. And thank you, Professor Renuka, and everyone in Vilat, CILT, and having this kind of program, which will be very helpful for the mentees. I would understand because I've been there like 17, 18 years ago, being a student. I know the challenges that we have faced and the support that we got. So it's very interesting to see that you all are having these kind of forums to enhance the knowledge of these young people, the future of the nation. And okay, so let's begin. There'll be a lot of fun stuff to learn, especially being aviation, one of your core areas that you would study. So thank you all who have joined from the Vilat, CILT, and from elsewhere. Let's dig it and see what we have to discuss today. Let me share my presentation first. Okay. Can someone confirm if the presentation is visible?
Yes.
All right, great. Let's begin. Right, so powering the skies, smart warehousing and logistics for next-gen airline MRO. So you would see some buzzwords over here, I would think. Some of you might be aware about some of these buzzwords. Smart warehousing, next-gen MRO, and these are the keywords you might be hearing. Especially in this decade, with the advancement of technology, the things are being dramatically, being improved, and the things are dramatically changing. So I'm going to talk about the aviation industry, especially with an aspect about MRO. We'll come across these terminologies in the next few slides, and then you will get to know what it's all about. So what we are going to do is the presentation is basically broken down into key segments. I'm going to have 7 different segments in this presentation. And at the end of the session, there will be a Q&A session. So you can note down any questions that you would have. I would try to answer as much as possible I can. So first of all, I'm going to give you some kind of a background about what airline MRO is, and in a fast evolving world, how the landscape is changing. What are the challenges that we are having and where we are going? And secondly, I'm going to talk about the strategic importance of warehousing and logistics in the MRO industry and also in airline MROs specifically. And then I'm going to talk about the challenges that we face in traditional systems, in traditional setups, and why we need to go into smart warehousing and innovations in logistics and things like that. I'm going to give you some case examples from my organization as well as from the globe. Then finally, we are going to talk about the road to 2030s. That means the future. What would be there for us and the key takeaways and kind of a framework. I mean, if anyone wants to, implement smart warehousing and logistics in your organizations, kind of a framework that you can think about, and it's more of a strategy part of it. So in the first 3 segments, I'm going to basically talk about the MROs and give you some kind of background understanding so we can delve into the details. So we'll talk about MRO, why it's important in warehouse and logistics, few examples, and we will be having a more engaged session. I'm gonna, open some polls as well, so you can respond to that, and we will have more of an interactive session, I would believe. Right, let's dig deeper now. First of all, let's talk about airline MRO in a fast evolving world. Right, I have a question for you in the beginning of the session itself. Let me know about what are your travel, patterns during the next 5 years. How many times do you expect to travel by air? So if you don't have any plans, you can, choose the answer 1, or if you have infrequent plan, like 1 to 4 times during the next 5 years, you can choose a second answer. If you think about, you might be traveling maybe twice a year or even annually. For an example, you can select the answer 3. If you're a frequent traveler, you can select the answer 4. I would like to see the chat, and I would like to see what are your responses are, because the thing is, we can get some understanding what are the travel patterns, travel habits of this crowd, and we can see where the world is going and whether we are aligned with that and things like that. Yeah. Okay, I can see the responses are coming. Okay, 3 times per year. Tivanka, Dr. Priyangani, 1 or 2. Prasad Champika, 3 times. Okay, right. Option 2, 3. All right. Good. All right. I think I got an idea. So option 2 is the most, selected option out of all the answers. So that means there is some tendency that everybody is kind of trying to travel in the next 5 years. Yeah. So that means it's a good trend, I would say, because the thing is, especially after the COVID, the industry has really, returned back not where it was, but it surpassed. So that's why I wanted to understand this question, and it also shows that what sort of population that we have in our countries, and what are their habits and what are their thoughts. So these are some informatics from the ICAO, that is International Civil Aviation Organization, about the global passenger market in the next many years. It's around 35 years. So the projection has been done until 2050. If you look at this information, you can see somewhere over here in 2019, we have basically peaked. The pre-pandemic global passenger volume was the peak. It reached up to 8.5 billion people during that time. And it suddenly dropped, due to obvious reasons. Then actually what happened was by around 2024, we have surpassed it. That means we have reached up to 104 percent, that is 9.5 billion passengers in 2024. That means we have no longer below the COVID levels, but we have surpassed it. So it's a very good turn back. Actually, I can see that it is from the travel patterns. Whenever I try to travel to Sri Lanka, the flights are always full. A lot of tourists are coming to Sri Lanka. Not only that, in the Dubai, the hub that we are working with, the flights are almost occupied. The seat occupancy is too much, and we can see from the operation point of view as well. The Emirates operates most of the aircrafts. Only few aircrafts are in the hangars and are grounded. So the operation is so high. So that means, I mean, there's a huge increase of demand for global passenger volumes, and it's going to surpass, and it's going to be 284%, 244% by 2050, with the annual growth rate of 3.6%. So what does this mean is that there is a huge demand. That means there will be new aircrafts coming into the industry, and this also means that you need to basically gear up to cater to these demands, because if you do not gear up, then you will be having a trouble, because with this advent of passenger volumes, there will be new technologies coming in, new things that you need to do, more operations mean you need to maintain your equipment as much as possible. Right, so that's kind of a sneak peek on the global passenger market. Let's go to the next slide to get the understanding on the remaining topics. Right. So I'm going to give you a little bit of background understanding about the aviation ecosystem. So aviation ecosystem is basically broken down into two. You have civil aviation and the military aviation. When you say civil aviation, it's all about the commercial, aviation, commercial airlines that we usually travel with, or it can be a general or charter, aviation. So the difference between commercial and charter is basically commercial has basically scheduled flights, but the charter is something that you can always go and book by yourself. It's only for your use or something like that. Military is completely different and has different regulations altogether. But then again, one common factor between both these, sectors is that MRO. It is basically the foundation which gives the critical support across both these sectors, and it's kind of like the bloodline of the industry. Okay. Right. Now we come to this buzzword MRO. I'm not sure whether you have heard about this terminology. It's an industry term. It's not only available in aviation, but also they are in all the industrial sectors basically. So let's see your knowledge about MRO. Can you key in what is the terminology that you know about MRO? Let me see if you responses and see if you are getting it. Okay. By the way, do you see the full slides that I'm presenting, or do you see the speaker view? Can I hear back from you?
Now it's okay, Visuddha.
Okay.
It is in presentation mode.
Okay, fine. Right. Okay, we are getting some responses. Manufacturer, repair and operations, maintenance, repair and overhaul. Okay, Namar Bandaranayake. Okay, you have given the correct response. MRO stands for maintenance, repair, and overhaul. Yeah, this is the industry term. It's applicable to aviation, shipping, industry, and manufacturing, and all those places basically. Okay, let's look at a sneak peek in MRO in a nutshell in aviation. So I'm gonna show a small video, and then we'll recap on the concept again. Let me know. If you can't hear or something like that, let me know. I'll play the video right now. Wait a second. I think I did not share the audio. My apologies.
no sound.
I'm sorry, you can't hear?
Yeah, sound is not coming.
No, we can hear. We can very well hear.
Okay. Thank you. Thanks very much.
Okay,
Go ahead.
I'll resume.
Everyone else, please, can you all hear? Because I can hear, of course. I don't know whether others can hear, please. Can you please
We can hear.
give
We
us a
can.
thumbs up?
I
We
can
can
hear. Yeah.
Ah, yes.
I also
they
can hear.
Yeah, of course.
Thanks, Professor
Yes,
Renuka.
we can.
Okay. Right. So you have seen what kind of activities that we do on aircraft, and what you have seen is the first 3C check, which was done on the A380 aircraft. So A380 entered to service in Emirates in 2008, and we are the largest A380 operator in the world. And so these are the maintenance activities that we perform on these giant aircraft. Okay. Right. Now I'm going to talk about the heartbeat of the aviation reliability. So just to give you further understanding about aviation, what we are doing and how we are doing and things like that. So basically the maintenance activities that we do in the aviation breaks down into different segments. So you know the terminology is the maintenance, repair, and overhaul, and it's basically doing a silent operation to make sure that the aircrafts are flying safely, reliably, and it is airworthy and comply to regulations. So these are the four different requirements of the MRO function, so that you don't need to worry about anything as a passenger. You don't need to worry about whether it has gone through the repetitive maintenance, whether it has been serviced, whether it has been gone through all the regulatory compliance requirements. You don't need to worry about. Right. So there are a few sectors that you need to think about. So especially the line maintenance. So line maintenance is nothing but whenever a aircraft comes, lands, and before it is taken off for the next time, it has to go through certain maintenance procedures. It has to go through some servicing requirements, maybe certain replacements, and in certain cases some if there's any the base maintenance is basically what is happening in the hangars. These are called heavy checks, and people who are quite familiar with the industry might have heard about A checks and C checks. Two different checks. Checks are nothing but that what you do on a aircraft is kind of similar to what you do on your vehicle. So vehicles, usually you service your vehicle every 5,000 hours. Not 5,000 hours, 5,000 kilometers or 10,000 kilometers. So vehicle is kind of it's an equipment, needs to be repaired, needs to be overhauled, needs to modify at certain times. But then again, aircraft is a much more of a bigger piece of machinery, and it's more complicated. So you need to break down all the maintenance requirements in certain pockets. So that's why you have different intervals where the maintenance activities are being done. So apart from line and base maintenance, so you have to basically overhaul the engines, which is basically providing the power for the aircraft, and these propulsion systems need to be upkept at all times. And apart from that, we need to overhaul the components as well. For an example, if you have engine, within the engine you might be having fuel pumps, there can be hydraulic pumps, or various components that needs to go through certain repair activities, so servicing activities, so that it is airworthy, it will not fail during the flight, so that you can have a reliable flight. So these are all four major avenues of maintenance activities that an airline is usually performing. And depending on the size of the airline, these activities can be done in-house, or it can be done outsourced as well. Right. Let's talk about how the MRO lifecycle integrates with the warehouse and logistics value chain, which is the topic that we want to discuss today. So basically, the warehouse and logistics is, having a very pivotal role in the MRO process. So when you talk about MRO, any maintenance activity in an aircraft or in any other industry, there are three things that you need to, fulfill. One is you need to have the parts, because you need to replace the parts due to, certain interval requirements that it needs to replace. And or maybe the parts are basically failed, component failures are there, or there can be certain regular requirements. So there can be certain other scenarios where the parts need to be replaced. So you need to replace the parts. Okay. Second thing is, to replace parts, you need to have tools. Okay. Without tools, without proper tools, you can't do this exercise. Third thing is, you need to have the resources. The resources are basically engineers, technicians, and mechanics who perform this activity, right? Okay, so engineers and resources, the mechanics, let's keep it aside. Let's take the spare parts and the tools. These two things are basically doing a pivot role, because I mean, out of the three, these two is at most necessary to be there to perform an maintenance activity, and it has to be there on the right time at the right place, so that you can perform the activity and release the aircraft to service. So how do we do this? So in a typical airline, we have stores kind of distributed in the line area. That means to say, when you are getting into an aircraft in the tarmac, we call them as gates. Okay, there are maintenance activities are being done. I mean, aircraft comes, lands, and it goes to a certain checks, goes to certain servicing activities before you gets into the aircraft. Okay, so these are the line maintenance checks which are being done. To supply materials to these line maintenance activities, there are forward stores. So you need to strategically position these stores in different places of the gates, so that you can quickly turn around the aircrafts. For instance, in Dubai International Airport, which is one of the busiest airport in the world, which handles over 90 million passengers annually. So there are 4 different store points, line maintenance store points for us in Emirates MRO, which we strategically placed in different places to handle the aircrafts. And in base maintenance, you need to have a main distribution center, because that's where the core activity is being done. When I say core activity, the majority of the tasks are being done in the base maintenance, in the hangars. So when you say, I mean, I gave this terminology A checks and C checks. C checks usually happens every 3 to 5 years time frame or something like that. It depends on the aircraft and the type. And when it comes to the hangar, it remains there for longer duration of time. It can be starting from 10 days to even 2 months. So during this time, the entire aircraft will be stripped, as we have seen in the previous video, and the structure elements of the aircraft will be checked for degradation or certain cracks and things like that, various other things. And the components are basically then serviced, overhauls, come back, and then assembled back to make the full aircraft. So this is what the base maintenance does. So majority of the tasks are being done in the base maintenance area, where a main DC. For instance, the main DC we have in Emirates in Dubai. We have over 20,000 square meter facility, which only handles more than 140,000 SKUs. We operate basically 2 types of aircrafts, Airbus A380s and Boeing 777s, not 2, 3. Actually, recently we started A350 operation as well. So 140,000 SKUs and different quantities, starting from nuts, bolts, washers up to the engines. Third engine is engine and component overhaul. You need to make sure the handling traceability certification of the parts is utmost important. And the fourth is the modification and upgrades. When I say modification and upgrades, these are basically the mods that you perform in an aircraft. At the latter part of the presentation, I'll show you what we are doing nowadays for the A380s and Boeing 777 fleets, where we kind of modernizing the entire aircraft. Completely removing the existing seats and completely refurbishing. It's a retrofit activity. And most important, the last one is the technical records and compliance. So tracking of the part history, shelf life of the materials that you are keeping, and the calibration intervals of the tools that you are maintaining is utmost important in this industry. Yeah. Right. So typical functional areas of MRO in terms of warehouse and logistics is these, functionalities. You would see these. If you work in a airline MRO function, or if you heard about it, if you have studied about it, you might see these terminologies. These are very interchangeable from airline to airline. Depending on the scale of the operation that you do, you might have all these functions. So part of those functions, some of the functions can be outsourced, or some of the functions can be kept in-house. So you basically need to have the receiving function, and you need to have material inspection and certification, which is utmost important in the industry. And this is where basically the supply chain as a whole, material management as a whole, speaks to the regulation of the aviation industry. So when I say the regulation, every country has their local regulations. And basically starting from the International Civil Aviation Organization, which dictates, basically sets the governance model for the aviation, and it translates into the regional regulatory authorities. For an example, European Aviation Safety Authority, EASA, or FAA, Federal Aviation Authority, and Sri Lanka, it's the Civil Aviation Authority. Likewise, so these authorities are there to basically policing the aviation industry. So material inspection is very important from that aspect, because every material that you receive has to be inspected. We'll come across these things in a later slide as well. Then, as a normal, warehouse, you are basically doing the receiving, put away, picking operations, managing of the inventory, and things like that. Very specific parts of aviation industries, basically we are doing this last mile delivery, because this is very important, especially in the case of in the magnitude that we operate in Emirates. We have 12 base maintenance hangars. That means it's huge hangars. All the C checks are being happening, and then we have more than 50, 60, delivery points within the, Dubai airport itself. And on top of that, we have more than 140, outstations to manage. So we have to manage the spares delivery to these destinations. If not, you have to dispatch or ship these items to the outstation facilities, where you have to manage outstation stores. If you don't have outstation store, you need to manage it with the flying spare kit. Like for an example, if as you are having a spare wheel in your car, aircraft is also having a spare kit if there's no support in the outstation that you're flying to. And you need to manage line stores, tool management, and AOG. AOG is a term that we are going to talk in a few minutes. So I'll keep to that for now. Right. So with that, we are basically completing the first section, which talks about what MRO and what is the significance of having warehouse and logistics function, and what are the activities that we perform. Now let's talk about how strategic the warehouse and logistics in an airline MRO perspective. Right. This is time to have another question from the audience. What is the question? The question is, what is the largest commercial aircraft in the world? I'm sure that you might know the answer. So just type it in to see whether you know the answer. So what is the very first answer? Taraka Vijay Singh, Prasad Champika. Okay. All right. So it's none other than A380. Airbus A380 is the largest commercial passenger aircraft in the world so far. Right? Why this question? Why did I ask this question? to show you the magnitude of what is happening. Okay, now let's look at the second question. How many individual parts would you think contained in an Airbus A380 aircraft? There are four choices that you can select: less than 100,000, less than 1 million, 1 million to 5 million, or greater than 5 million. What are your guesses? How many individual components, individual parts, which might go into building an aircraft A380? Let's see some of the answers. Any guesses? Is it answer 1, 2, 3, or 4? Okay, I'm getting answer 3 after a little bit of pause. Is it because everybody's going to internet and searching, okay, how many parts are there in A380 aircraft? Or did you guess it properly? Anyway, nevertheless, yeah, I'm getting the right answers. The right answer is 3. Very well done. Right. So 380, A380 is basically containing 4 million plus parts. And there are 40,000 or more tracked components. When I say tracked components, these are basically components which has to be, which can be used, reused, and it has to be tracked. That means we have to track back to birth. You need to track all the removals, all the installations, and all the cycles, flight hours, and everything of that sort. So A380 is a beautiful piece of machinery which comes from 330 plus suppliers across 30 plus countries, and it's a massive undertaking. And I mean, when the aircraft flies, I mean, this is my favorite aircraft. I mean, when it flies, I mean, you see it's flying very slow, but then again, it's flying so fast because of its huge size of nature. You can't see how fast it's moving. Right. So what this means is basically 4 million plus parts that goes into making an aircraft. So it doesn't mean to say that are we going to keep all these materials with us so that we can maintain? No, it is not the case. So you are going to certain reviews and you understand what parts that you need to keep as insurance parts, as repetitive wear and tear parts, what are the strategic parts and things like that. Okay, so let's talk about this. That's where the intelligence or the importance of this novel technology comes in. Right. So basically, the warehouse and logistics is nothing but a strategic movement. It's not about just the storing, or it's not about the movement of parts. It's basically making sure that the airline is profitable and doing its operation and meeting its core objectives. When I say core objectives, let's go through this one by one to understand what does that mean. Okay, first thing is you need to make sure the aircraft is available for commercial routes. Basically, that means if your aircraft is grounded, if you don't have the parts at the right time, at the right place, you won't be able to fly the aircrafts, right? And the second thing is you need to optimize the cost, because for the sake of keeping inventory, you can't keep all the inventories just to make sure that you have, a kind of a reliable operation. No, it is not the case. You need to always hit a balance, as we do in any inventory organization. Either it is aviation, either it is manufacturing, anywhere. You need to look at the cost optimization. You need to have the balance inventory and balance the service levels. Turnaround time is really, really important, because the thing is you need to minimize the ground time that aircraft stays on ground. The reason being, aircrafts make money when it flies. Okay, so that means we need to make sure the aircrafts are there in the sky for a longer period of time, and we should minimize the time it stays in the ground. So how can you do that? You can do that by making sure your maintenance slots are properly planned. And for these maintenance slots, you have the proper material, proper tools, and the resources principle you can follow, and within the time duration which is given by the planning teams, you can release the aircraft back to service. If you can't release the aircraft back to service, that means there will be disruptions on the operations plan. It's like I mean, for an example, I mean, think about a small kind of what do you call car leasing company. Let's say there are 10 cars, but you have this many customers. Okay, so you need to manage these 10 cars. You need to do the servicing of these cars. You need to make sure that you provide a proper service level that you agree to the customer. And if you are keeping the cars out of service, that means you will not be able to make sure that you adhere to the promises that you have made. And if you reduce your availability levels, that means you have to look at other ways of meeting those. Similar to that. Next thing is about the regulatory compliance. I mentioned previously as well, the complete part traceability is a must in the aviation industry, because the aviation industry is, it's a famous saying, aviation is written in blood. I mean, the industry is more than 100 years old, and starting from early 90s, and it has been developed to a stage where we are with a lot of fatalities and accidents and things like that. And every incident, the industry has learned, introduced new legislations, new safety criteria, things like that. And because of that, the regulatory compliance is always a mandatory thing. Yeah, so you need to maintain this regulatory compliance, which requires you to perform a lot of clerical activities. Okay, we'll talk about this in a later time. Technology, end-to-end visibility and digital transformation is more than required nowadays, because in a complex environment, you can't do all these things. I mean, because the activity itself is so complicated. Moving on. All right, let's talk about scope of material management in a typical MRO. Similar to the other, industries, management acumen, we can break it down to three levels: strategic objectives, strategic planning, and execution. Day-to-day tactical level of activities that we do. Let's look at what are the strategic activities that you need to perform in terms of material management. You need to look at the fleet support planning. That means what sort of a mix of aircrafts that the airline is having, and how we are going to support this, and what sort of materials that we are going to maintain, what are the levels, and things like that. We have to standardize the materials and the sourcing strategy as well. For an example, if you have a couple of types of aircrafts, you can try to standardize certain materials which is within your control. For an example, if you operate Boeing and Airbus, you can't standardize, of course, everything, because obviously the types are different, the manufacturers are different, but there are certain elements that you can play around. For an example, these are called buyer furnished equipments, especially. Or certain components as well, you can specify during your, the purchase agreement. You can say, okay, I'm gonna use this supplier for the internal, the seats, basically, maybe for the in-flight entertainment. So you're trying to standardize the material and have a proper sourcing strategy. And most importantly, you have to have a proper network design of the warehouse and part hubs. As I told you, in the Dubai International Airport, we have strategically placed warehouses in the tarmac area and also in the hangar facility, and these are also strategically designed to support the maintenance activity which is going on. Then we look at the planning point of view. You need to forecast the demand, because if you are having checks happening, for an example, aircraft comes and goes every landing cycle, you need to do certain maintenance activities. And every week or every 2 weeks, you need to do certain other maintenance activities, some servicing and replacement and things like that. And every 3 to 5 months, so 500 flight hours, so few flight cycles, you need to do certain maintenance activities. And every 5 years, so there are a lot of activities which is going to happen. So you need to plan. For these planned maintenance activities, you need to demand, forecast the materials, and then you need to provision the materials. How much is required, where it is required, what is required, things like that. And rotable pool and safety stock planning is also very important, because rotable is a terminology which is being used in the industry quite oftenly. Rotables are the components basically fits into the aircraft, which can be overhauled, which can be used repetitively. And for an example, I'll give an example. Engine in an aircraft, it never dies. If an engine is used for a certain number of flight cycles, let's say 10,000 flight cycles, it can be removed, sent to for the overhaul activity. You can bring it back to the zero life. With that, you are starting a new life. So that means these are the rotables which can be rotated around, and you can always for this you need to have a float. You need to manage a float. So that's all about planning. Execution. Now we come to the tactical level. So you need to look at the purchasing. How do you coordinate with the vendors? How do you place the purchase orders? How do you communicate with them? And most importantly, then next is the receiving and quality control, which we talked about, is aspect of the warehousing and storaging, picking, dispatch, and returns is the next thing. Right. Let's look at the functional domains. This will basically improve your awareness about things that I'm talking about, because I'm going to give you the strategic importance of material management functional domains, which we are in our industry, why it's important. So material planning and provisioning basically looks at optimal, inventory, and material forecasting. We talked about predicting part requirements. These are the things. Remember these key elements, because when we come to the smart warehousing and smart logistics, we are going to talk about these things again. In a traditional warehouse, we are doing with maybe, spreadsheets, maybe very rudimental, ways of working, maybe planning, all manual activities. But then again, when you come to the smart, you might be doing it in a completely different way. Okay. Right, purchasing and vendor management, warehouse and operations, logistics, transportation, all these things are basically happening in a rudimental way. But these are the functional domains that we make sure that is there to support the MRO function. Right, let's talk about aviation specific requirements in warehouse and logistics so that you would get a clear understanding. Okay, I mentioned about this rigorous quality control. 100% of the time, the parts have to be inspected and documented, accepted procedures has to be there. Okay. Back to birth traceability. I told already about this. You need to have, if you bring a component, if you buy a component, you need to have the back to birth, when it was manufactured, who manufactured this, who given the certificate of release, and when it entered the the supply chain, and which aircraft it was fitted to, when it was removed from that aircraft, where it went for overhaul activity, when it came back. So like that, this goes to different cycles. This is utmost important, because we'll talk about the last point. You will understand why it is important when you talk about that. So to do this, we need to have digital documentation chain as well. So we have a very robust archiving function. You need to keep everything handy for inspections and things like that. Specialized storage is a must in aviation industry, because we are talking about different materials, different temperature, humidity controls, requirements, and hazmat materials, and ESD protection. ESD is a terminology we use in aviation very frequently. Electrostatic discharge sensitive. You need to follow special procedures to inspect these materials and to store when you're doing that as well. So there are different storage requirements. So regulation basically specifies these requirements, which requirements that you need to specify maintain. Part segregation and classification is also very important, because you can't mix serviceable items with unserviceable. Let's say, for example, aircraft comes with a defect and you remove a certain component, and this was just kept with the serviceable materials, and it ends up in the warehouse. And let's say in the next interval, when the part is required, these unserviceable components goes to the aircraft and it fits, but due to some reason it was not detected. The operational test was satisfied. Aircraft is flying now. All of a sudden, 35,000, 36,000 feet above the air, ocean, you find a problem, and it can lead to a calamity. So segregation of serviceable, unserviceable, repairable, and all these things are very, very important in this industry. You need to tag the parts properly. You have to track the parts properly. This is where the smart technologies comes into play, and it's very handy. Okay, audit readiness. So this is what I was talking about when I was talking about the back to birth traceability. The aviation is a place, industry is a place that it's been continuously being audited. Rigorous audits are taking place every month, couple of times, by the regulators, by the internal quality, by various regional and local institutions. So it's been done. So it's very important to maintain this information. Right, let's talk about traditional systems quickly. I'm just doing a time check. Okay, we will quickly go through the traditional systems challenges that we are facing. In traditional setting, you might be having the legacy software integration issues. Information is not flowing that fast, limited visibility so that you can't do the forecasting properly, and it is always reactive. So imagine that you are always doing a reactive activity. That means you wait until the aircraft to break down. You wait until something breaks down, and then you initiate the ordering and all that stuff. I think we have seen these examples in the history in certain airlines, but it is not the way that you have to manage. You need to always predict. You need to basically forecast the demands and have a proper planning exercise. And processes can be manual and it can be disconnected and depends on veteran knowledge. Now, this is where it is very important. Aviation is an industry where people basically value the experience that you have, the number of years of experience. But then again, you can't rely always on the veterans. There should be systems, there should be procedures, there should be norms. So this is where the smart systems may come in handy. So the operational impact of having these kind of system challenges is that you might have extended downtimes, and if something goes wrong, you might need to spend more. And you might have excess inventory also in wrong locations if you didn't do a proper planning exercise. AOG risks, we'll come to that in a moment. Compliance documentation and gaps is also another thing. Okay. Another question, right? What is an AOG? This is an industry term. People who are aware about the aviation industry might know this term. Let's see who can answer this question. What are your guesses? AOG. Let's see if someone knows or someone can guess the response to this question. What is AOG stands for? Nilufa Nizam, on the spot, aircraft on ground. Right, very good. We have a very, very knowledgeable, cohort today. I mean, answering all the questions. Glad to see that. I mean, you are very much aware about, industry, what's happening around you. Right, rush aircraft on ground. So this is a situation where we need to avoid at all cost. Okay. Right. This is where every second counts in aviation logistics. Okay. So think about a situation. I'll tell you a situation. Okay, let's say you are there, you are trying to fly. Now you have travel plans, right? So you are there in the aircraft. Aircraft is about to fly, and you got into the aircraft, and the captain speaks on the intercom and says, "Okay, we have a trouble. The aircraft is declared unserviceable, so you have to be, disembarked, and we will come back. We will tell you when the aircraft is ready." Okay, something has gone wrong. Now it means the AOG has been declared. Aircraft is grounded. The clock starts now, and every second counts. Right? So what needs to be done? First, the resources should come, the engineers, technicians will come and troubleshoot and find out where the fault is. The fault isolation has to be done. So it takes considerable amount of time. Doing the troubleshooting and fault isolation itself requires a lot of spare parts, because you have to swap certain systems, swap certain parts, and see what has gone wrong. So once it is identified that you need to, basically the part is, declared unserviceable, you need to do emergency sourcing. You have to find out where this part, can be sourced from. Is it available locally? I'm for an example. I mean, if you are flying with Sri Lankan, I mean, if you are in the Colombo base, if the aircraft is, not airworthy, you can see whether the part is available with Sri Lankan Airlines in their store in Sri Lankan. If Sri Lankan is flying to Dubai, Sri Lankan should check whether they have any parts stored in Dubai. If not, can they loan from someone else? Are they in any pooling agreement with any other airline so that they can, basically borrow a certain component from that airline? So this is how this industry is basically working. You should have the parts. Either you should buy it from someone, or either you can pool or you can loan from someone. So there are different agreements. So you have to look at emergency sourcing, where we are going to take this. They need to transport this quickly, so that if it is not the base, the sector, for example, Sri Lankan Airlines, if it is not Colombo, somewhere else, you will have a trouble, because if you don't have the part, you need to ship the part either from Colombo, either from the manufacturer, wherever in the world, and you need to send the people from Colombo to that station to get it repaired. You have to do all these activities, and you have to do immediate installation. So this is where the planning, forecasting, and all these things comes very handy. Where the help you immensely. Right. All right. So to give you an understanding, a single AOG event might cost around $100,000 per hour in revenue loss, passenger disruption, and operational impact. And this figure is usually for a Boeing 777 aircraft. In a major hub, if something happens, this is the cost impact. It can vary depending on what you operate, where you operate your aircraft, and all that stuff. But you can understand how much negatively it impacts the profitability of an airline. Right. Now we are coming to some fun stuff. So we talked about the aviation in a nutshell, the MRO. We talked about warehousing, what role it has to play in this industry, why it is important, what are the challenges in traditional, warehousing systems and logistics systems, and AOGs especially. Let's talk about the digital transformation, about smart warehousing. Right. Let's have a look at how we have progressed, how the evolution has taken place in the warehousing in the past. The manual activities were there in all the stores before 1950s and all that. You had paper-based tracking systems. You didn't have barcodes and all those things. You had paper cards, stock cards, and things like that. And then there was a time the barcode systems were introduced. First, digital inventory tracking was basically introduced. Then sooner you got ERP systems, which has certain material management functionalities, material requirements planning, and things like that. And more importantly, warehouse management systems where centrally manage all the activities that happens. Right now, when we come to the era of last decade, we talk about the IoT and automation, where we talk about connected devices and the machines, which basically gives you insights, which basically kind of change the things on its own, can make decisions on its own. And then we come to the AI-driven warehouse, where intelligent decisions are made by the systems themselves with the help of the humans, right? So this is the evolution that taken place in the warehousing in aviation. And what has happened during this journey, this transition, is that you have improved your precision, your speed, and your agility. Right. What defines a smart warehouse? So smart warehouse is nothing but you are going to improve the way that you work. That means you are going to have the real-time visibility. That means to say you can instantly find out where the item is available and you can track this item. For an example, if the item is coming from the vendor until it lands in your receiving department, you can track it. Once it enters the warehouse, you can track it over there as well. And when it goes to the maintenance activities and when it goes through its return journey, you can also track. So real-time visibility will be there. And most importantly, robotics and automation plays a very pivotal role in smart warehouses, where you have AGVs, automated guided vehicles, or AMRs, autonomous mobile robots, or ASRS systems. ASRS stands for Automated Storage and Retrieval Systems. So these are the things which improves your efficiency and gives a productive output, and reduce the reliance on human, because humans are usually doing a lot of mistakes. Now with these technologies, you can basically augment the way that you are using humans. They can do more strategic roles, they can do more planning, and they can improve the reliability of the process. And then we come to the IoTs and sensors. I mean, IoT and sensors are basically used for monitoring of the environmental conditions, condition monitoring of the equipment, tracking of the parts. So when you look at the environmental monitoring, so when I told you that warehouses in aviation has to have different types of warehouses, different environmental conditions, especially in the environment conditions we operate in the Middle East region, very hot and humid region. You need to maintain the temperatures below a certain level of temperature and humidity, and sometimes cold storages and freezers and things like that for different classes of materials. And you can look at condition monitoring of your equipment. So you can look at failure rates, the reliabilities, and improve the way it works, especially your AGVs and AMRs. You can track the parts with the IoTs and sensors. And predictive analytics is very, very much important. Here we are talking about demand forecasting. Demand forecasting is not limited to the warehousing, not limited to the purchasing, not limited to logistics. It starts somewhere earlier when aircraft maintenance plans are basically being generated. So you're talking about forecasting the demands of a certain part which needs to be replaced, and prediction of certain part failures and things like that. So that is where we are going to hit. And to do this, you need to have the system integration. You need to have warehouse management systems. You need to have ERP systems, MRO systems. So basically, MRO system is nothing but another sort of ERP, a customized ERP, which is dedicated for the industry, aviation industry. We call them as MRO systems. It has all the ERP functionalities starting from finance, procurement, planning, provisioning, and all those activities. So it has to be connected. Okay. It cannot work in silos. That is the most important thing, because if you have disconnected systems, what you are going to do to connect these, you need to have manual processes, maybe data entering, maybe a very rudimental way of integration. So this is not going to work. You need to have system integration. And mobiles and wearables on the go operation is important. You might have handhelds, tablets, AR glasses. We'll talk about this in a minute in proceeding slides. And digital compliance tracking is also very, very important, because you are handling a lot of activities. You are archiving function that I talked about, back to birth history tracking, and everything has to be digitized. So we'll talk about technologies out there which does these activities. Digital threads in action. So what are the threads in action to make sure the airline MRO are working seamlessly and connects? Starting from forecasting and planning, we talked about just a while ago, AI driven demand planning is important. You are talking about planning your, components, when it is going to fail, and then when the item is required and when it has to be procured. So let's talk about a typical example over here. Let's say, I mean, you understood. Okay, let me take one component, a hydraulic pump. Looking back at the history of this hydraulic pump and the failure rates and reliability figures and all that stuff, we identify that, okay, this is going to fail in 500 hours or something like that. Okay, let's say hypothetically, let's assume that. Okay, now that means if you have AI driven demand planning, this information is readily available in the AI data engines. So you can basically predict, okay, this is going to basically, fail in 500 hours duration. And these are my maintenance activities that I have to do in the next year. Okay, these are the times that it's going to come. And these are the lead times for me to initiate these purchase orders. These are the stocks that I'm having at this point in time. These are the stocks I'm having with my repair agencies, which is yet to come after repair. So now let me plan, let me forecast this item and plan it and place the order immediately. And procurement, so the order is basically placed, automated, it's validated, and it's been received. Before receiving, it's shipped out from the vendor. You get the advanced shipment noticing. You get the material. It has been tracked because it has RFID tags or geo trackers or things like that. So you basically monitor. Once it enters the warehouse, IoT enabled, condition monitoring is helping you to track the condition of the warehouse. So you keep this item in the condition that prescribed by the manufacturer. Yeah. Now, just-in-time principle, the aircraft comes, lands, so it's planned already. You need to replace this part within the shortest ground period, ground time. Let's say 1.5 hours to 2 hours is the ground slot. Within that time, you need to replace this part. Resources are allocated, the parts are being ordered automatically, and it's been sourced from the closest location to that particular stand. Okay, and it's been brought to that stand earlier as possible. Everything is done basically automatically. Now, part is available. The technician or the mechanic can take the part, issue the part using mobile devices, take the help from the AR, VR glasses to do the troubleshooting and things like that, and installation and all that. Now we are talking about the returning and disposal. So returning of the removed component goes back to the reverse logistics chain, and it's been tracked again. This goes in this cycle. So this is how things are basically connected, and this is how it is tried to be achieved. Right. Why smart warehousing is a business case? So everybody might be thinking, why we need to do all these? I mean, we are doing it today. Why we have to do it tomorrow? Because it gives a lot of benefits. And at the end of this session, we will talk about why it is a necessary. Okay. First, let's look at why it makes sense. Why? Inventory accuracy. You can improve the inventory accuracies by a significant amount. You can reduce the AOG response times a significant amount, 30 to 40%. You can reduce the order to pick, order to delivery cycle times by a significant percentage, improve the labor efficiencies, and you can always comply with your digital logs. So this is where a business case can be easily built up to have smart warehousing practices. Right. So we talked about smart warehousing perspective. Let's look at now logistics, because warehousing and logistics is basically kind of sometimes it's interchangeable, go hand in hand. Supply chain, all these, buzzwords are all connected to each other. But logistics as its own has its own, challenges. Let's see how we are going to solve those challenges intelligently as possible. So it's kind of a nerve center of the airline, because you have to make sure, remember our objectives. You have to make sure the aircraft availability, the uptime, and you have to make sure the turnaround time is always made optimal. Okay, how do you do that? You can do real-time tracking with GPS and IoT-enabled devices. You can do dynamic route planning so that your material can be sourced from the closest location, the fastest, delivery, shortest lead time, and all these factors considered. You will have a seamless connection with your MRO systems, integrated platform. When you say integration, it's real-time communication between multiple systems. Let's say you have a ERP system, places the purchase orders. You have a MRO system which looks into the maintenance activities, like planning of the maintenance work, creating work cards, assigning it to the, in the shop floor and getting it done. You might be having warehouse management systems, looks into the warehouse, aspects of how to store, how to issue, how to improve your picking cycle times, how to deliver it fast, things like that. So all these are connected and it has to be seamlessly integrated. So this is where the challenges comes in the legacy systems, which we'll talk about in the later part. Predictive analytics. We talked about this. Prediction of the demands is utmost important, and it is a possibility and it is being done. These tools are available out there. The forecasting is done using AI tools, and you can predict reliability indicators, and everything can be basically balanced. API driven communication. So API driven communication means you have APIs of these new systems, which are basically cloud native and true SaaS products and things like that. You will always have the, connectivity, uptime, all 99%, 99.9% uptime, and all these, parameters. Control tower driven visibility. So you can look at end to end how the things are moving. You can track the parts, you can track your resources, you can see what is happening, where the pain points, where in the operation you are having bottlenecks and things like that. Yeah. So it's basically what we are trying to achieve is a predictive, connected, smart logistics in innovation in action. So bits and pieces of these is basically done in the aviation. I'll talk about certain use cases and case studies in the next slide, so you will understand this more and more. So these buzzwords that we are using, the artificial intelligence, machine learning, and these all these things basically help us to make this logistics activity more innovative as possible. Yeah. Right. Okay, let's move on. Future of logistics in airline MRO. Let's talk about few tools out there in the industry which is being used to improve the logistics value chain. Right. You might have heard about this word, digital twins. So it's basically nothing but a carbon copy. Like you are a physical person and you have a virtual copy of yourself. So it's a virtual copy of a kind of a physical system, or it can be a process, or it can be anything. So you're basically, what you are looking at is, rather than investing on developing something from the scratch, you are basically creating a digital twin, and you are kind of putting the parameters into play, and you kind of model how the operation is taking place. I will, in a moment, I will show you a video which lets you understand this concept to a certain extent, because it's kind of new in the aviation. Also, it is kind of new. It is coming into play, but you might have seen this in various industries. For an example, I remember way back in 2006-7, when I was in the university, we talked about simulation of operations in a house. So but so far in the industry, after joining, I have not seen actively people are using these tools. But with the digital twin solutions, this is more and more intuitive. You can model a warehouse from scratch, and you can see, you can change the parameters, you can increase, decrease certain things. For an example, let's say I'll give you an example. So Emirates is operating now 3 types of aircrafts, right? So, and we are adding this 4th type of aircraft type in the next year or so and so. So when that's been added, that means you are bringing more inventory, new parts, new volume of inventory. Now we have a warehouse, it reaches a certain capacity. So are we going to meet the demands with these new inventories that we are bringing in? Okay, what sort of bottlenecks, what sort of constraints that we are going to have, how we are going to solve? Are we going to redesign the warehouse, or are we going to source new warehouses for this particular purpose? How are we going to support the maintenance operation? So all these things can be basically plotted in a digital twin application, and you can see how it is basically being done. And yeah, so it's very intuitive. Predictive demand. So this we discussed already. Predictive demand based on flight hours, maintenance cycles, and reliability indicators. You can predict the demands, and you can make sure the part is available at the right place at the right time when it is required. Okay, we talked about back to birth history tracking, right? So blockchain is a distributed ledger. So basically, you can have the part lineage tracking. So you can have a blockchain which contains all the information, and just by scanning a QR code, you would be able to see the entire history of this aircraft. This is kind of a very difficult part right now in a legacy way of operating. For an example, when you are selling an aircraft, because I mean aircraft similar to vehicles are being also sold between it's been bought by different people throughout its journey. So when you're selling, you need to make sure that you give all the documents, the entire history of that aircraft, which components. Now A380, remember there are 40,000 tracked components, right? So all these 40,000 items should have a history starting from the birth up until that moment, how many flight hours, how many cycles, when it was removed, when it went through the the overhauls and things like that. So if you have the blockchain, it's just single click or a scan, you will see all the histories because it's getting basically connected. Right now, everything is manual, it's in paper. So industry is slowly, gradually moving into this digital, records keeping, but it is not yet regularized, but it is the trend tomorrow with this advent of technology. Autonomous delivery is something which has been already, kind of implemented by certain, aviation organizations in the air side and last mile solutions as well. So there are restrictions in the air side usually. I mean, when I say air side, the airport, within the airport perimeter, using autonomous delivery is kind of restricted because local regulations are there, especially the drones. So still the industry is going through these, improvements basically, because we have to make sure that you are not hampering the operation because of bringing these new technologies, but it is something which is under discussion. Okay, right. So I got a small video clip, so you can watch this and understand the digital twin in warehouse term. You would see how the Google Maps kind of concept is basically transpired in a warehouse, and how you can model this kind of a situation and how it improves your planning activity. Okay, let's watch this.
There's no sound, Visuddha.
No sound. Oh, let me stop sharing and try again.
To capture every
Can you hear
detail
now,
of their surroundings.
Dr. Priyangani?
And this creates a 3D map, a digital twin.
Okay. Let me start from the beginning because you might have
And
missed
use
the
Google Maps. It has revolutionized the way we get around, navigate, and explore new environments, simplified to a radical degree.
The Kelvin Group is now on the verge of revolutionizing intralogistics in a very similar way. In the international research project Arabic, we have worked with universities to develop the AI platform of the future. This technology can be described as Google Maps for intralogistics, allowing the real-time localization of all goods and forklift trucks in a warehouse to become reality. In the future, warehouse trucks will use their range of sensors and cameras to capture every detail of their surroundings. And this creates a 3D map, a digital twin, to the warehouse. AI-based algorithms use this data to intelligently control their warehouses.
At Google, we are excited to be involved with Arabic. What we see from Arabic is just the beginning of the potential that this solution offers, because we are talking about nothing else than the Google Maps of intralogistics.
Like Google Maps, Arabic is a platform economy, and we are working with strong partners such as IBM and Google to industrialize it.
Kion is clearly a front-runner in intralogistics with its AI developments within the Arabic project. With its mapping of indoor spaces and, above all, collection and evaluation of real-time data, automation with AI, this really is a project that thinks ahead. Of course, the next focus is on industrialization. Kion and Google Cloud are working together and using AI to break new ground in
All right. So, in the interest of time, I'd like to move forward. So, you kind of got an idea about digital twins. So, this might, help you understand how
logistics
it's working.
and
Right.
use.
Let's move on. I'm going to talk about now some case studies, success stories as well. Let's go through quite many to catch up. So first, I'm going to talk about my own organization in Emirates Engineering. What sort of digital initiatives that we have done to bring the things up to speed. It's at the starting levels in certain cases. In certain cases, we have gone quite far. So we have this system called Ultraman system, which is our mother system. It's like our MRO ERP, where it provides you the end-to-end MRO activities, like starting from the procurement, planning, purchasing, and also maintenance planning, maintenance packages, production in the hangars, work cards management, inventory management, delivery, and all those activities. So it's basically entire suite of applications which we have. It is basically integrated throughout the landscape. Just to give you an understanding, so Emirates as organization, as I heard, has around 400 different systems in its operation. Works with seamlessly integrates it with many systems depending on the area that you operate. When it comes to engineering, engineering has over 100 systems. It is our wish that to have a one system, but the problem is that there's no one solution fits all. So we always go with certain small systems, but always try to integrate. So that's the strategy we have taken in the last decade. Because rather than inventing things and bringing bigger systems, you can do quick solutions and in an agile way, which is the way of managing things in this era. And so that's how we handle. And we also have mobile inventory application, which is used for the on-the-go access to the inventory and get the parts issued and picked in the tarmac, in the warehouse, and all these different places. And we use RFID technology to track the safety equipment on board an aircraft. So safety equipment, I'll give you some examples. So you have seen the passenger masks falling down when the aircraft goes beyond a certain altitude, because the pressure becomes in a depressurized situation or something like that. And you might have seen in certain situations, passengers are requiring medical oxygen. So these are all, safety equipment. And beneath every seat, you would find a life jacket. In case of an emergency, you would be using this life jacket. And all this safety equipment has to be tracked before the flight can depart. We have to make sure all the life jackets are there underneath each and every seat, and each and every life vest is having the required shelf life, and it is not tampered with. So how do we make sure that it is happening? We are basically having a device with a RFID gun, and we just walk on the aisle in the aircraft, and within like 5 seconds we complete the complete sweep of the aircraft and find out if there are any non-compliant items. So this is basically kind of a safety check, because you make sure you use the technology to find out what are the the issues in your supply chain, issues in your maintenance activities. So you correct that using the technology. So this is being implemented since 2018, and we one of the pioneers in implementing this RFID technology in that domain. So we are building the future for smart warehousing as we speak. Currently, we are working on a project to implement Manhattan Active WMS product in our warehouse, environment. We are, as we speak, we are doing integration mapping between the Ultraman system, which is a very painful exercise. We'll talk about this in later slides, because integration is so much important. Although all these buzzwords, AI, ML, and all those things are there, when it comes to systems integration, the real pain is over there. It has to speak to each other. It has to be compatible. We have done a couple of proof of concepts using warehouse bots for point-to-point transportation. These are basically autonomous mobile robots. We have not implemented it yet in the facility in Dubai, because we have plans to, open a new facility in the Al Maktoum Airport in Dubai World Central. It's like 50 kilometers away from Dubai current international airport. So we'll be having a bigger facility, fully automated, warehouse environment where you'll be having SRS and AGVs and all that stuff. So we have done proof of concepts, and we are getting ready to, implement it over there. And AI-based demand forecasting is something was there in the discussion for the last, like 5-6 years, and now it has, gained some traction. Because the thing is, the mainstream applications, the MRO systems might not come with AI-based demand forecasting so far. It might, but then again, you can look at certain other solutions, third-party solutions. You can do the integration for the forecasting work. So it has gained some traction. These are some other initiatives in the Emirates landscape, which we have done so far. So because Emirates as a company is quite huge, we have more than 260 aircrafts. We operate 240 plus destinations, and we have over 100,000 workforce. And so different parts of business, they have done these implementations. So as we speak, with partnership with Boeing, the maintenance teams are doing POCs for drone assisted aircraft inspections. So you don't need to do these inspections using humans. You can identify maybe tail strikes, maybe lightning strikes or things like that, or damages using drones. And already our ground handling arm called the NATA has implemented and integrated autonomous drones for cargo operations. So they are basically monitoring the environmental conditions, counting the inventory and different activities. So cargo operation is very unique. So they have found a good business case over there, which they have implemented. And we are also interested in this, might come in future as well. Right. Lufthansa Technic is a pioneer in MRO. Delta is also another MRO. So they have done these innovations in various platforms. Lufthansa basically have this aviator platform, which does the AI forecasting. And they also have integrated planning systems. They also do predictive maintenance algorithms using AI as well. Delta Tech, similar to us, they have done RFID tagging of components. More than 200,000 components they have tagged. And that's an investment, because when you receive the component, you tag means you need to invest on that. You have to have manpower to do that. But then again, you are gaining the benefits of doing all these activities. 99.5% inventory accuracy is something very good to achieve. And they can also handle their AOGs as soon as possible, because they can track the materials fast as possible. Singapore Airlines Engineering has also done certain, events of the using. I have started using this mobile application, which is being used for the parts issuance and for the mechanics to book the parts, issue the parts, and things like that. And Air France has been using machine learning for forecasting. Finally, I'm going to talk about Airbus. Airbus has done this POC of delivering of parts in their production hubs from warehouse DCs to the manufacturing lines. So they are piloting this. They see 75% improvement in the delivery time, productivity improvements, and integration with the digitization. So these are the few examples of case studies which has been done in the industry by the industry leaders. The thing is, aviation as an industry is quite slow and to adapt the technological innovations, not like the other industries, because we'll talk about this in later slides as well. The regulation kind of hinders these kind of developments, but then again, slowly, gradually, it is coming there. So you won't find aviation MRO warehouse which has all the sorts of technologies, but there is a glide path for that. We will talk about that in our last section, which is about to come. Right. Let's talk about the road to 2030s. What are the key takeaways? And we'll talk about a framework. What are the challenges, barriers, and all those activities. Let's talk about shaping the next decade with key future trends in airline and MRO. I'm going to talk about few of the technologies in a very high level. We are going to have hyper connected systems. I already talked about seamless integration is an utmost necessity, that is between different systems, WMS systems, MRO systems, ERPs, OEMs, and all those. So what is required over here, that you need to have ecosystem where you do this communication in real time way. So that means you cannot drive this kind of strategy with legacy system. You need to uplift your upkeep your legacy systems, and you need to have cloud native API first kind of systems so that you can do these kind of innovations. So that is a must. But then again, in the aviation industry, still we see a lot of systems are there in the mainframe, but there will be a time that it is required to migrate these to new stacks of technology. Augmented workforce. So we talked about having AGVs, AMRs, and all those things. So, but at the end of the day, most of the picking would be done by the workforce that you have, right? But you can augment the way that they work. You can have augmented reality, mixed reality, and all those things basically to help the person to do his job correctly, rightly, accurately as possible. So this equally applies to maintenance activities as well. So we have seen in the maintenance activities as well as in the training of the cabin crew and other crew members. We have seen heavily we are using this augmented reality. AI powered forecast we kind of discussed, and digital twins, you got an idea what we are going to do. It's about simulation. Circular supply chain is nothing but you are trying to reuse the material that you have in the supply chain so that the impact that you give to the environment is quite low. So this is a new thing in kind of in aviation. Because you try to repair as much as possible, but sometimes you can't repair all the components that you have. At a certain point in time, you need to discard it. But new repair schemes are being introduced. You try to reuse as much as possible. So these kind of sustainable measures are being taken in the industry. Sustainable warehousing at the end of the day, because when you're talking about big DCs and a big operations, we are talking about huge spaces, right? So that means you are consuming a lot of energy, and carbon footprint is so high. So you have to look at how you are bringing down the impact to the environment. And so more or less now the trend is that we are using a lot of electric equipment in the warehouses. This has been there since 10-20 years ago, but it's being further improved, and more energy saving initiatives are being also done in the industry. Right. Next, we are going to talk about enablers of success. So this is very important because you can have the best organization, you can have the financial backing, but then again, the initiatives like this can fail due to various reasons. Like first thing is that you need to have the commitment from the executive sponsorship, should understand the necessity of doing improvements in the industry, because when it comes to the business case, always these technologies are not cheap. These are very expensive technologies. So you are measuring it with the benefits that you are getting, right? So especially in this region of the world, the labor is quite cheap compared to the other parts of the world, like Europe and other places. So you naturally think about, okay, do I really need to invest on these kind of smart technologies? If I invest on people, if I bring more people into my warehouse, I can get this done at a very lower cost. But is that the way that we should proceed? No, because it is not scalable. It is not the future, and you will not be future ready, and you will basically miss the race. So that's not how it has to be. So executive leadership is very important, and change management, cultural transformation, because now we have people in traditional warehouses. You have people who are basically working, right? So their skill levels are not that great. But then again, you need to uplift this, the training skills. A person who can use AI tools, a person who can use a system, a person who can use digital, applications to do his work. So these are the changes that we need to do as well. So you would get the resistance to change as well. System integration is very important. We already talked about it. Training and upskilling. Yes, workforce has to be digital ready, and partnerships with the vendors. Right. From insights to action. So what we need to do and what are we going to get? So these are the things. So we already talked about how and what are the things that we need to do and what are the barriers, what sort of support that we need. So this is what we are going to get. Action. Okay. To have digital infrastructure first. This is the first thing. You need to have cloud native WMS, true SaaS products, API architecture, mobile first interfaces, and all those activities. This is not uncommon in other industries. I mean, I have seen in the FMCG industry, this is in at a very advanced level, not what we have in aviation, because aviation has its own restrictions and things like that. So, but this is a must. Data and intelligence. You need to have the data. When you have the data, you can analyze, you can predict, you can run lots of things, you can do wonders with the data. Because I mean, this is one thing which is very important, and what is the most valuable entity in this world in future. It is the data. If you have the data, you can do many things, right? People and skills, we talked about automation and robotics. It's more scalable. I mean, these AMRs and AGVs compared to traditional automation, like you have conveyor systems and things like that, this is more scalable. You can implement it. You can implement it in a modular way. Okay, you can use it in various aspects. You can use it for receiving. You can use it for picking. So picking robots, transporting robots, and counting robots. Various other things you can do. Sustainability and compliance, we talked about. We have to look at paperless logistics. So we also have in Emirates in engineering, we have this goal of going paperless by 2030, if I'm not mistaken. So there are certain initiatives are being done to go paperless, because in aviation we use lots and lots of paper in the warehouses, in the production floors to print the work cards and things like that. On aircraft, when it is flying on the flight deck, you have this a paper called technical log sheet, where the pilot is writing down all the issues, or the fuel uplifted and all other important information. It is done on a paper. So as we speak, in Emirates, we are doing a trial POC to go digital on that. It's called electronic tech log. So a pilot would be having a basically iPad, enter all the information, it's connected. So these kind of things are happening in the industry. Right. What are the barriers to smart transformation? What's holding us back? What's holding us back is the legacy systems. Legacy systems are difficult to integrate, but it is not impossible, because I told you there are certain mainframe applications still have being used in the industry. So, but it works. Still, it works. So, look at ways and means of going around that and doing the integration. Investment challenges we already talked about. The business case would be really, really difficult, because I mean, costs will definitely outweigh the alternative. So the opportunity cost is something that you need to look at in that. Workforce resistance will be there. There will be data silos and poor visibility and regulatory constraints. So industry is working quite slow because of the regulations, but we are getting there. Okay, so these are the barriers we have right now in the industry. All right, towards 2030, a vision for MRO. What do you need to think about? We need to think about integrated ecosystems, right? It's from the planning to parts delivery. We need to have ecosystem where everything is seamless. Okay. We need to have AI-driven agility. You need to predict forecasting. You have to anticipate the AOGs, aircraft on ground situation, real-time decision making, true artificial intelligence and machine learning. So these are not just buzzwords. It's been done. It's been basically practiced. Intelligent infrastructure, autonomous warehouses. It's nothing new actually. It's there in the FMCG, pharmaceutical, and all those industries. In MRO, in aviation is also it is there to some extent, but it has to be increased, improved. Sustainable operations, people at the center that uses digital tools and they are upskilled to work on these new systems. Right. So this is my final takeaway on this presentation on the seminar. So there are three things basically. So the first thing that we talked about is the MRO. Okay, aviation as industry, the MRO, and then we talked about the warehousing, and we talked about smart logistics, and we talked about different case studies and what we need to do in the industry. One thing that you might have understood is that warehouse and logistics is not having the same back office function or the same rudimental way of storing materials and issuing materials. This is not where we operate. It's equally same for aviation as well as other industries. I mean, I'm sure not even not in the regions. I mean, especially Sri Lanka, especially the Middle Eastern region, which has a lot of opportunity for new systems and things like that. But then again, everywhere we see that new things are coming. People are using new applications, trying to improve the things, bringing new tools as much as possible. Not sometimes it's not a significant investment. You are bringing small tools and apps as much as possible to improve the way that you work. So if you are going to be if you're going to do smart warehousing and smart logistics, you cannot basically stay back. You need to improve the way that you are working, because performance of the airline, the reliability of the airline depends on this. Remember the first slide we talked about, the growth of the industry is basically from 9.4 billion to 20 plus billions, a 244% increase in the next 25 years. In the next 25 years, things will dramatically change. Aircrafts will change. Aircrafts are currently powered with the kerosene, but then again, you are looking at sustainable aviation fuel, hydrogen powered aircrafts. New and new systems are coming. So new and new systems means you have to be up on the game to improve your part of the activities that you help these new improvement of technology to realize. So that means we talked about that, right? So supply chain management is a strategic activity of the MRO function. So you need to upkeep your game. So you need to do that. Technical adoption is essential because it is not a nice to have thing anymore. It is a must to have. If you don't have it, you will fail. So it is the future we are talking about is an integrated digital and intelligent place. So you must have that. So success in these ecosystems depends on what we do today, not just keep it over there, and it is where it will lead to transformation. So that's basically end of my presentation. I have another video to showcase to you. So basically, I would think that you might have got a clear understanding about when we say powering skies, when we are looking at next generation airline MROs, these are the things that we need to do in order to upkeep ourselves within the industries, in the industry itself. So those are the things that we need to do. Okay. So just as a recap of my presentation, I'm going to show you something really important, because we talked about maintenance activities, we talked about retrofits and mods. The next video I'm going to show you is basically how we are modernizing the aircraft cabin of Emirates A380. We recently started this project of modernizing all the cabins in all the aircrafts, because we have a big problem in the industry that new aircraft types are not coming in. So you need to be up on the game. So Emirates is always up on the game. They are improving their product service line to customers. So this shows two things. One is how we are trying to improve ourselves, give a better, product to our customers, which is our core competitiveness, and also how these kind of activities are connected to the warehousing and logistics and overall, supply chain management discipline, because we are talking about coordinating with hundreds of vendors, bringing the shipments from multiple places of the world, storing it at strategic places, and getting it implemented, and all these maintenance activities. So it's kind of a well orchestrated symphony. So where you are achieving your objectives. So with that, I'm going to end the presentation for today. I hope that you might have got a good idea about the MRO industry, warehouse and logistics, what we are doing, what is the future entails us, and how we can be pioneers in this industry. So give me your comments after the presentation. I'm sure we will be having a Q&A. So if you have any questions, I would be able to clarify some certain things if I know to my best knowledge. All right. Thank you. Let me play the video. If you can't hear, just let me know. Over to you, Rem.
Thank you, sir. What an insightful and eye-opening session. I'm sure each of us is walking away tonight with valuable key takeaways and a renewed passion for innovation in aviation logistics. And now we open the floor for our Q&A session. If you have any questions, please feel free to unmute yourselves and ask directly, or you may type your questions in the chat box and we will address them for you.
Good evening, sir. Am I audible?
Yeah, I can hear.
First of all, thank you for an insightful webinar.
You're welcome.
There are two questions I would like to know. First one is, can you please explain a little bit about how MRO and flight planning connects, like you explained in brief, but maybe a little bit how flight planning and MRO connects, and like maybe in a real case scenario. Other one is, so there are concepts like linear programming that we all learn at university. So in the practical world, how does it apply for these types of tasks that you do in operations, especially in airlines and these operations? Thank you.
Right. Right. First of all, let me talk about the first question about MRO and flight planning. So basically, it's I mentioned that it's an orchestrated, activity. So flight plan is nothing but so you have certain schedules that you need to operate, right? So when you want to operate on a certain schedule, let's say, I mean, usually in Dubai airport, we do around closer to 500 network departures a day. So when you have network departures of 500, you need to have certain level of availability of aircrafts. So you need to balance these. So there are planning departments who looks at these, availability of aircrafts versus the demand that we are having, and then see what is available. So this availability is basically predicted from the beginning. So you have a plan for the next 1 year. So you have a kind of a long-term plan and a short-term plan. You are looking at daily on a daily basis how you are maintaining these the availability levels. That availability levels are basically given to the MRO, because MRO does the function, does the basically the aircraft scheduling. So that means, let's say Emirates has 260 aircrafts. I have these destinations to fly. So how can I plot this? So these all are basically done using certain tools. And then I look at what is the remaining. The remaining is what I can basically use for the maintenance activities. I can't use anything above that because it's going to affect my the commercial plan. So this is always a balance. So all are connected. You have a commercial plan. Commercial plan boils down to an operational plan, availability, the capacity that you have, and how much you require, how much is the surplus, or the less negative quantity. So this you need to balance. This always goes hand in hand. Did I answer your question, or do you want me to clarify further?
Yeah, it answered the question, sir.
All right. So about the linear programming, all these techniques, not just linear programming, the techniques that we basically study are basically used to optimize the performance, right? So optimizing the performance is basically driven by the algorithms that you have set forth in the back in the systems. So there are various tools back in the systems used to derive at a certain optimization level. So any system that you look at now, the same planning exercise, planning activity that I talked about, I have a demand, I have capacity. So how I can match this? So this is where your techniques come into play. So it's not just one technique; it will be multiple techniques. And I mean, these things have been basically evolved over the years. So the programming of the softwares for specific activities, especially the optimization of the resources, optimization of network planning, optimization of the maintenance schedules, and all those things are basically done in the backend. So you use this primitive, the mathematical, equations and all that stuff. But then again, you have, developed models, right? So you combine different models together and you arrive at a certain, answer. So that's how it's been done. So whatever you are learning, it's helpful. But then again, these are small bits and pieces, elements, which comes into a bigger equation. If you apply it to a warehouse, just look at the transportation or the travel distance of a picker in a warehouse, how optimized his path has to be. So all these are defined by a warehouse management system, right? So it is defined by the algorithm runs by certain config that you have done in the backend, certain parameters that you entered, certain constraints. So on these constraints only, the system is going to give you the best result. Okay. I hope I answered it. Oh,
Yeah, thank you so much, sir. There's a small another question we have.
Yep.
You mentioned about you have like there are around 4 million separate parts connected to an aircraft. So, and also you have a kind of a plan, like even a small part, there's a number of flight hours that it can operate. So, do you have an expected lifespan for each part connected to an aircraft, like
Yeah.
for all the parts?
Yeah, so every part, every component has expected lifespan. So that is what we are going to target. I mean, let's say the expected lifespan. Let's say the hydraulic pump example that I have given. If I know within 5,000, flight hours, this hydraulic pump is going to fail, this information will come. Based on that only, there will be a prescription from the equipment manufacturer, and it goes into the aircraft maintenance plan. Before every 5,000 hours, you need to make sure in a grounding you replace this hydraulic pump. So that's what goes into the maintenance plan. That's what goes into the work packages. That's how the parts are being removed and replaced. So So every part will be having this information, but it will be improved because you cannot predict everything, right? Manufacturer says, okay, 5,000 hours with a certain safety factor, he might have, provided that certain conditions, but the conditions might always vary. Okay, so that's where the reliability indicators comes into play. If you are operating an aircraft on a fleet, you know what is the reliability. This part fails not in 5,000 but 3,000 flight hours. Okay, now this is a new information. This new information can be used by the manual prediction forecasting models as well, or else in AI it can be quickly detected. So yes, so that's how it's basically linked.
Okay, thank you so much, sir.
You're welcome.
So there's one more question in the chat box.
Okay.
Are there any specially designed software or systems used by Emirates to track and forecast the aircraft maintenance periods?
So there are not, if you look at, two things we are talking about here, tracking and the forecasting of aircraft maintenance period. So I think you might be referring to tracking of the components. So tracking of components, yes, there are some systems that we have, developed small applications. For an example, we have system called track and trace, where we track the material once it's, issued from the warehouse until it goes to the, the final destination. We kind of trace it. It's not a very sophisticated system, but it does the work. So we want to improve these things as well. When it comes to the what's the second part is the aircraft maintenance period forecasting. So forecasting is done using our Ultraman system. So Ultraman system has certain tools to do these period triggers and things like that. But then again, there are novel technologies, better systems which does this activities. But then again, this is a combination. Okay, you have MRO system. MRO system has certain capabilities, and you have humans basically looking at certain other practices, parameters. So you basically combine both things together and you come to a conclusion. So this is where the AI and ML may come into the picture in future. We are not there yet. So these kind of things can be well predicted using AI and ML. Yeah.
Thank you, sir.
Right. Are there any more questions?
Visuddha, I'm Champika. I have one question for you. Yeah, you always talk about AI and ML how it can be applied to improve the process in inventory management. In Emirates, up to what level you use AI and ML at the moment?
So AI and ML we use in bits and pieces in here and there. I can't say that we reach to a level where we can say that we are a pioneer. No, but in bits and pieces. For an example, we are having discussions about this AI using of AI forecasting tools, and we are talking about ML being used in certain applications. For an example, this. But is this the GPT tools that we are having? So you kind of go and ask a question and gives basically the response. So aviation basically works with the manuals and instructions and things like that. So you have to always go to a PC and go and read that aircraft maintenance manual, find out information. So people are working in the back end, try to have this neuro linguistic search, machine learning combined together. Basically, you ask the question, you have the generative AI provides responses going into the procedure manuals and all that stuff and get the response and give it to you. So people are working on that. And another example is that we kind of similarly have these chatbots in aviation, in Emirates, in certain places. So AI is being used in different places for forecasting point of view. Not much there, but there are discussions on that. Yeah. The other thing is the machine learning. So the systems that we are implementing, for an example, this Manhattan Active Warehouse Management System has the AI ML capabilities to certain extent, not to a great extent, but it is there. So it's evolving, it's improving. Yeah. I hope I answered the question.
The way it's proceeding and penetrating, you think that will integrate to a great extent in near future? Is fully run by AI like?
I think so, because that is what we basically predict. Like when we go to the new facility, we are looking at basically fully automated, warehouses. So it's more connected. We are talking about smart hangars. We are talking about drone inspection. So the decisions in these kind of systems, you can't take the humans together. I mean, it's too much of a complicated, kind of orchestration that you need to over there. So I think, I mean, at the industry, it's in a primitive level, but the tools are getting there. I mean, as you have seen the case studies, different airlines have done, these implementations in different places, bits and pieces, not holistically, right? So holistically, we will be getting there, but it might take time. I mean, my best guess would be, 10 years down the line, you might see a lot of things, changed, and you might see a lot of AI tools being used in aviation for the product offerings and also in back office functions like this MRO and all those activities.
Okay, thank you, Visuddha.
Yeah, thank you, Shambhavi. Right, do we have any other questions? So
Okay, Prathagi, I think there is no more questions. We'll wrap it up.
Thank you, everyone. Now, to officially close the session, I would like to invite Ms. Kumari Gamage, Vice Chair Membership Development at Village Sri Lanka, to deliver the vote of thanks. Over to you, Madam.
Thank you, Prathagi. Good evening, everyone. As we have come to the conclusion of this insightful and engaging webinar on powering the skies, smart warehousing and logistics for next-gen airline MRO, it's my privilege to extend a heartfelt vote of thanks on behalf of the Village team. First and foremost, a big thank you to our esteemed speaker, Mr. Visuddha Piyathilake, for sharing his expertise, experience, and valuable insights with us. Your insights have truly inspired us to rethink the future of logistics and warehousing in the airline industry. And also, special thanks to our chairperson, Professor Renuka Hera. Your presence, guidance, and leadership is the biggest strength of our Village team. Thank you for your participation and sharing inspiring words with us today. I would like to appreciate our project chair, Dr. Priyangani, for organizing this event to discuss about timely required topic. Your leadership and commitment are greatly appreciated. And also a special thanks to our compere and moderator, Ms. Prathagi, for ensuring smooth flow of conversation throughout the event. We are also grateful to our participants today for your time, attention, and thoughtful questions. Your engagement has made this event success. Finally, a big thanks to organizing team and technical support team for managing this event seamlessly behind the screen. Our video production team, Irashi, Prathagi, Kusal, Suini, Sudam, Hafsa from our CILT office, CILT secretarial team, and membership development team of Village. Your hard work and dedication are deeply appreciated. We hope today's sessions has provided valuable takeaways and sparked new ideas. Let's carry forward the knowledge gained today and strive toward a smarter, more efficient and sustainable future in logistics and warehousing in the aviation industry. Thank you all once again, and we look forward to seeing you all in our future events. Stay safe and good night. Over to you, Prathagi.
Thank you, Madam. And with that, we conclude this evening's webinar, Power Up Your Flight Path to the Future. Let us continue to inspire, innovate, and elevate the future of aviation and logistics together. Wait for another exciting webinar in the near future. Thank you all. Stay safe and stay connected.
Thank you, Prathagi. Thank you very much, Visuddha, for the
Thank you, madam.
insightful session. Good night, all.
Thank you so
Thank you.
much.
Good
Mr.
night.
Piyathilake. That
Thank
was
you.
a wonderful
Thank you.
session, of course. There were lots
Yeah.
of new learning out there. So many thanks once again. Thank you.
Thank you, Ms. Professor Renuka.
Professor Renuka.
Thank you.
Thank you.